Okay, since we're at 2:03, I'm going to go ahead and start and introduce our next speaker and get rid of the frog in my throat. It's a pleasure to introduce Daniel Gruffat, who's an application scientist at Nanome currently, and has probably the shortest and sweetest bio that we were given, describing himself as a computational structural biologist working on structure-based drug design in virtual reality. I did just want to add that I went on your LinkedIn profile, and I know that you have both a Bachelor of Science in Biology as well as a Master of Science in Biology, specifically in computational structural biology. Daniel is here today to talk to us about exploring new tools for remote collaborative structure-based drug design. And so with that, I will turn it over to you.
Thank you very much. I'm just going to share my PowerPoint. Well, hello everyone. Thank you for attending my speech today. I'm very glad to be here. My name is Daniel, and yes, I'm a structural biologist. My research has been all based in silico tools for computational structural biology projects. Today, I'm very thrilled to be here with all of you exploring new tools for structure-based drug design. I will be talking about Nanome, of course, which literally blew my mind from the beginning, and still today, about a year and a half later since I joined, I'm still amazed every day with all the new developments and new releases that we on the software that very often come about. So yeah, join me in this not so long presentation. I hope you enjoy it. So here we have, back in the 80s, we had a keyboard and mouse as a computing interface. That was not very useful these days, even though we transitioned to the touch screens in the 2000s for the mobiles, and that was kind of a huge improvement in terms of computing interface. But the future, which is actually the present these days, it's the AR/VR computing interface, augmented reality and virtual reality. It allows for a much more intuitive interaction with complex data, and it's really the future. Well, again, the present really, as you'll see. So what happens with traditional two-dimensional methods is that there's always a risk of information loss, right? You don't get to see a lot of the nuances of the three-dimensionality of your projects, your protein target, for example. If you happen to work on proteins, you can see from left to right how there's more and more three-dimensional information. However, even the one all the way to the right, there's not a good amount of information that you can share properly with your teammates, because everybody is different. Not everybody has a good three-dimensional understanding, and to communicate this across teams, this structural information, sometimes is challenging. And so this is where 3 dimensions and virtual reality comes to improve the experience. There has been past attempts at 3-dimensional visualization, such as this CAVE system in the University of California. But we've been hearing from the community that these are actually static, these are expensive and not very helpful, really. They don't allow for a lot of interaction with your proteins or your models or anything like that. So here's where Nanome comes to play. Nanome is intuitive, where you can interact with your virtual molecules, just like if you were really interacting with the molecules themselves. So here, this is a footage of mixed reality, actually, where a person it's interacting with the virtual world. And here I am with my colleague, Edgardo. We are actually getting inside an antibody, and we are just having a discussion in there, taking a look at residues. You might have seen there's also a PDF file that we loaded into the application. And so, well, you can import, structures from databases such as RCSB, PDB, PubChem, DrugBank, or even from your local machine, your proprietary data. And Mo, Maestro, and PyMol files are supported. So if you happen to have sessions from those softwares, you could load them in Nanome and take a look at them and keep editing and keep doing drug design sessions, and then save again all that session that you just created. So, like I said, it's a very intuitive software. You can see here in the left, there's a virtual hand that is rotating a side chain of residue. You can do just that with your own hands. You can do measurements, like we can see in the right panel. With the action tool, you can just make any measurements. You can also do chemical modifications on the fly to the ligand and many sorts of things. So that's been proving really helpful in having a high impact in terms of drug design sessions. For drug design sessions, like I said, you can build functional groups with the MedChem tool. Here we have an avatar here. It's Mike, our medicinal chemist. He's literally building, he's in the binding site himself with Steve, our CEO, and they're literally adding functional groups to the ligand as they discussed. And by the way, they are in different geographic locations as they have this collaborative session. To the right, we have, again, another mixed reality footage. Here we have my colleague Edgardo. He's interacting with the protein targeting there. So Nanome integrates with any third-party computational chemistry applications that you might be using daily in your workflows. So it's a Python-based API, and it communicates. In this case, we are seeing an RD kit for chemical properties. You can create snapshots and compare properties against other snapshots. And as you can see, as the avatar is making modifications to the molecule, it updates in real time in the back in the two-dimensional panel in there. So you have a complete library of functional groups you can add. You can also delete and all these things. This is just one example, by the way, for chemical properties, but there's other plugins that can be integrated into the platform, such as molecular docking, for example, we see here. Right now we have a plugin with Autodog Smina, which is a fork of the popular Autodog Vina. And you can just select your protein target and your drug or ligand of choice and carry out a docking experiment in there. You will have your real-time atom scoring, a score of the free energy, and you can make some selections such as the number of binding poses and things like that you like to see. Here we can see how he's cycling through different dock ligands. If you happen to be a computational chemist, you might enjoy to play trajectories and molecular dynamic simulations. Here we can see two avatars. They actually did a measurement between two atoms, and it updates in real time as the trajectory plays. You can change the representation as well while in a loop. If instead you happen to be a crystallographer or a structural biologist, you might enjoy the electron density map features. You can modify the radius, opacity, the sigma values, as you can see here in this animation. Another thing that's, it's important to know that you can save your VR sessions for future presentations. You can export in PDB, SDF, MMCIF, even SMILE strings. So that's been shown very helpful for many teams working on in Nanome. Here we are getting into a binding pocket. It's very insightful, as you can see. So one of the biggest features actually from Nanome is not just the fact that you can visualize and edit and design your molecules, but it's also the fact that you can collaborate in real time with any colleagues, across sites anywhere in the world, really, and across teams. Of course, you can have computational chemists, medicinal chemists, structural biologists, or any profile really working in real time, having a session, and it works pretty smooth. We can see here how there's people joining from anywhere in the world, and that's been shown to really accelerate the drug design decision making in sessions. So that's been shown pretty cool. Really. So how has Nanome helped other organizations? Well, in many ways. For starters, Novartis. We've been working with Novartis since 2017. We connected their teams across San Diego, Boston, and Northern California, and we co-authored a paper, which is the one that I'm showing here, by which we developed this platform. And so, that was published in the Journal of Molecular Graphics and Modeling. And I believe it's available for downloading our booth, by the way. We've been collaborating with LifeArc organization, a customer in Europe, who is also connecting scientists across the UK, really. And they have been leveraging our software to build their own Python plugins to further enhance their existing workflows. So that's been also really cool to see. And they've been very happy with this application. Lastly, I want to mention this Oculus business case study that we just did recently, a couple of months ago, with Nimbus Therapeutics in Massachusetts. So that's a very interesting case study, by the way, that it just shows how they've been able to save tens of thousands of dollars by using Nanome. And the reason why that is the case is mostly because they were able to understand the nuances of the three-dimensionality a lot better. And even though they had a good option to send out to synthesize some drugs, when they went into Nanome, they realized that was not really the best option. That was an okay option. So they figured out the best option thanks to the virtual reality environment. And they describe all their experience in this case study, which, by the way, is also available to download in our virtual booth. And that's been really having a high impact as well in our community. So to finish, summarizing, Nanome's core, as I said, is a collaborative platform where you can meet virtually as your colleagues were right next to you, regardless of the geographic location. It's integrated with any of your existing computational chemistry tools and databases. And then it's very intuitive. You can just use your own hands and even your voice. It includes voice commands, the software actually. And so, it's been really helpful because of that. So this is pretty much it. Thank you all for watching. I'm happy to answer any questions you might have. And welcome to Nanome.
Wonderful. Great presentation again, Daniel. And it's a very interactive platform that you showed us. I really like the live demonstration in particular. And the floor is open for Daniel.
So I'll go ahead and ask the first question, and we'll wait to see if we get any in the chat. Daniel, that was a great presentation. It blew my mind as well. I think it's amazing what virtual reality and artificial intelligence can do together, and your presentation certainly highlighted that. My question is actually with regards to the system and training, and how long does it take for people to train on the system itself?
Unfortunately, you were breaking up a little bit. I couldn't hear you well. Could you please repeat the question?
Yeah, I'm asking how long it takes users to train on the system.
Oh, well, actually not that long at all, due to the software being very intuitive. That's one of the main goals we've had in mind when developing it, is precisely to having a low barrier of entry. So you don't have to have such an extensive technical background in order for you to use this type of softwares. And of course, we meet with the customers and we train them. We have VR sessions with them, and pretty quick you get familiar with it. Yes.
So pretty quick, like 1 or 2 sessions, or
Well,
can you
I guess it depends. Yeah, within a couple of sessions, you do get very familiar with the environment for sure. Now, for more advanced options, well, of course, you would need perhaps some more. But again, it's pretty intuitive and pretty easy to use. Yes.
Okay, thanks. I think we have. Do we have a question in the chat?
Sam? Yeah, we have 2 questions. First is from Steve Miller. He said, "Great presentation, and I'm excited about VR opportunities to explore. What are the biggest challenges for market entry?"
Biggest challenges for market entry. Well, some people are, I don't know, perhaps stuck in the past. They don't like all these new technologies sometimes because they think that it's too, like Kerry mentioned, perhaps it requires a lot of training, technical, but not really. People really end up realizing that, again, it's very intuitive and very easy. So, yeah.
Wonderful. And there's another follow-up question from his colleague, Mr. Derek Bone. He's asking, what equipment is needed for virtual meetings? Can user create their own content or need Nanome?
That's a good question. I guess you're talking about hardware requirements. Well, if you're talking about what you need to wear, that's the headset. In this case, it's a standalone, all-in-one device that's sold by Oculus, which belongs to Facebook. It also contains 2 controllers, so you can perform any actions within the virtual environment. And that's a standalone device. You don't need anything else other than internet connection, Wi-Fi connection to operate. Now, it's also possible to connect it to a VR-enabled computer, and by doing that, you can increase your computational power, of course. And if you happen to be working with a very large complex of proteins, for example, you might need to do that. But for the most part, this is not even needed.
And there, he has a follow-up for you. He's like, is it SaaS, SaaS?
SBAS? I'm sorry, what's that?
SaaS. SaaS, software as a service.
Oh, currently we don't do that really, but we're open to have that discussion. Yeah, why not?
And Steve also has a follow-up for you. He's asking, is the graphics card special or?
Good question. So, like I said, with the standalone device, you don't even need to connect to any computer, right? But maybe if you are to connect to any computer, if I remember correctly, you need a minimum of NVIDIA GTX 1060 for it to work properly. Recommended 1080 actually. But again, for most proteins, if they're not very large, you don't even need to connect your headset to a computer.
Wonderful. And does anybody have any other questions for Daniel, you can type it in the chat box over here. Alternatively, you can also connect with him. There is one question from Janet Pina asking, what is large for protein?
Good question. Well, this particular device can handle about perhaps 5,000, 8,000 atoms. I guess it depends. But, beyond that, you might just need to connect it to a computer, yeah. But, that's roughly 600 or 800 residues. Or sometimes you can go beyond that. There's not a clear cut, but I've been working with a lot of proteins lately, especially lately I've been focusing on coronavirus proteins a lot, all those main protease, spike protein, for example, all those. And you can work with those proteins, seamlessly without needing to connect it to a computer. But by a large complex, I meant, perhaps antibodies are a bit too large, and things like that. But other regular proteins, cancer targets like RAS and things like that, it's completely okay to, you don't need a computer for that.
Wonderful. Any other, I guess, questions or comments for Daniel? Well, I guess I'll leave the floor open for another minute or so.
By the way, I've been also working on GPCRs lately, and those are also fine to work with. They're not that big.
Great. Yeah, and there is one more question from Adrian Rubio. He's asking, what kind of lag among participants?
I'm sorry, what kind of what?
Lag, L-A-G.
Like lifetime between people on the call.
Oh, lag? Oh, so there's no lag. There's hardly any lag. The sessions are pretty smooth around the world, really. Like I am based in New York City, and the company Nanome is actually based in San Diego. We have sessions pretty much all the time, as you can imagine, and it works seamlessly. There's no lag, really. And I also have sessions sometimes with Australia, with Europe, and it works just fine. Well, that's assuming, of course, that your internet connection works properly. Mm-hmm, for sure.
And you can't control that, Daniel.
Right.
Any other questions or comments for Daniel and his amazing innovative platform? And I know from yesterday, Dr. Woody's talk, I know you guys are also working with Silicon Therapeutics as well.
Right. Yeah, I don't know if Dr. Woody Sherman is watching right now, but I want to thank you very much for his huge shout out. Yesterday was very nice, yes. And very nice speech he gave, by the way, too.
I'm just going to check one more time to see if we got any other questions or comments for Daniel. I think so far we are good. Dr. Karen, if you have any comments or questions.
I don't have anything further other than to say thank you. And Adrian said impressive. So
thank you very much. I'm happy to follow up with anyone that's interested. Just shoot me an email, and we'll take it from there.
Sounds good. Thanks again.
Thank you. Bye-bye.
And we will be, I guess, heading to the room for our next presentation by Dr. Krishna, a Senior Director of Alcoin Therapeutics. He'll be speaking about precision delivery of next-generation medicines for the CNS. So let's all head over to his room now. Again, precision delivery.